Section 27.3 is about the production of X-rays, and in this section we're mainly talking about the production of X-rays, and they talk about the intensity, the threshold voltage, and the shortest wavelength. Okay. Figure 27.7 shows a diffraction pattern that well, actually, this doesn't belong in this section because we want to talk about the production of X-rays, the intensity. Well, maybe, yeah. This really, I think, more belongs in section 27.4, which was talking about diffraction of X-rays. Um, the second figure, though, 27.8, gives a schematic for creating the X-rays. And in creating the X-rays, you're going to have the filament voltage is going to go through some filament. And the basic idea of this filament voltage is it's just going to go through the filament and loosen up the electrons, just kind of push the electrons out to the surface of whatever the filament is. On the other hand, the high voltage is where you're going to accelerate these electrons to a very, very high speed. And when they come and hit, what will happen is they'll come into high speed and then they'll hit the tungsten target there. This high voltage here is what we're going to call delta V, and it shows up in equations 27.8 and 27.9, delta V, delta V. Figure 27.10 shows an incoming electron and a target of the nucleus of a target atom, and this particular figure is kind of incomplete. To complete it, I'll do that nucleus of a target atom right there, and I will consider, instead of just one, I will consider an electron coming in this way, an electron coming in this way, and an electron coming in this way. Okay, and what happens is that this electron, it basically either stops completely or maybe bounces, but but its change, this is going to create the highest frequency of um, Bremstrahlung radiation, or the lowest wavelength of Bremstrahlung radiation. The second one, the electron kind of goes this way. It probably slows down, but it's going to create some other frequency less than F max, or lambda more than lambda min. And this one's going to turn even less, and will get its speed reduced even less. But the main thing is that this guy is going to produce the maximum frequency or minimum wavelength. Now they give this chart here that shows that talks a little bit about things. The actual maximum that they're talking about here, or minimum, is going to be right here. This is going to be your minimum wavelength. Right here, it's between 30 and 40 picometers. That's going to be the minimum wavelength that is achieved in this situation. Other things happen. For instance, this line and this line come from a certain thing happening where this electron will knock out an electron somewhere in the center of the atom and eject it, and then what happens is that other electrons further out in the atom fill in that shell, and when they fill in those shells, that produces these particular frequencies of radiation. So this exact figure is shown again in chapter 28 or section 28.6 under the topic of characteristic X-rays. And in fact, figure 28.14 does a little better job of explaining um, the Bremstrahlung radiation, because it says the shortest wavelength depends on the accelerating voltage. So that's the number there, between 30 and 40 picometers. So the relationship between the minimum wavelength, which is right there on the graph, and the accelerating potential, which you're able to determine by whatever kind of tools you have. That's the relationship between wavelength and the accelerating potential. And then everything else there is constants. H is Planck's constant, c is the speed of light, E is the charge on an electron. So you can see the relationship between the maximum frequency or the minimum possible wavelength. It says not all of the radiation produced has this particular wavelength because many of the electrons aren't stopped in a single collision. In other words, this one will go on, be deflected by another nucleus, and then maybe be deflected by several more nuclei before it completely gets stopped. But this one got stopped immediately, and that one is going to produce the maximum frequency, minimum wavelength light.